We're going to go ahead and wrap up Chapter 7 today. We're going to be dealing with infinite geometric series, recursive form, and iterations. A geometric series that goes on forever is called an infinite geometric series. Some geometric series converge, meaning they approach a single number. And they approach a single number if and only if R is between 1 and -1. And then if r is not between 1 and -1, well, then the geometric series would diverge, meaning if you would add them together, you would not approach one single number. So consider down below, we want to know if these converge or diverge. Well, if you look at the first one here, we need to look at what r is. You take one term divided by the previous term, and you end up getting 1/2, which means you're multiplying by half each time, which is between 1 and -1. So we would know the first number would series converge. It would approach one number, and we could go ahead and work that out. Now the problem on the right, when you take one term divided by the previous term, or even take 3 divided by 1, you get 3. This would diverge. You would not approach one number. And if you think about this, you're continuing to add larger and larger numbers each time, so it's going to keep getting bigger and bigger. Now over here, you're adding smaller and smaller numbers each time, so it will approach one particular number. So if r is between 1 and -1, we have a formula for the sum of an infinite geometric, but this only works if r is between 1 and -1. Now, down below, we need to go ahead and decide if these converge or diverge. But once again, you look at what r is. R is not between 1 and -1, so we know it diverges. When we look at problem number 2, 0.8 is r. That is between 1 and -1, so it converges. So if we need to actually find our series of our infinite geometric series, we can use that formula that's over here on the right. R has to be between 1 and -1, which you'll notice it is here. So we can just plug that into our formula. We have to go our first term, according to our formula, over 1 minus r. And I always like to put r in parentheses. So we could work this out one step at a time. You could type in the bottom and you get 1.5, and then you could go ahead and work that out, and you would end up getting, when you turn it into a fraction, -32 over 3. We can do the same thing over here. Now remember, that thing that the exponent's on is r, so that's your 1/2. The number that's in front of that that's being multiplied by is your first term. Well, there's really a 1 here, so your first term is 1. So when we use our formula, we have our first term over 1 minus r. Plug in our first term of 1, plug in r being 1/2, and we can use this because our r is between 1 and -1. So when you type this into your handy dandy calculator or work it out in your head, you'll notice you get 2. That's what you have to do for the sum of an infinite geometric series. Now, when we're dealing with the recursive formula, you're always told where to start, and you're always told what to do from one term to get to the next term, and that's what we're talking about here. When we're looking down below here, we are told that we're starting out at this. Then this rule says you take that previous term that you just had and always just add 10. So I take my -41 and I add, why don't I put down 41? Now we were given our first term being 40. and we add 10. Well, 40 plus 10 is 50. And then continue to do that and add 10, which is 60, and add 10, which is 70. And we needed the first four terms. Well, we have that. Well, when we do that over here, we'll start out at negative 8. And when we look at this, this is our previous term. And that subscript n matches this n, so that means it's the position of that previous term. So our rule says our previous term plus the position of that previous term. Well, when we're looking for here, our previous term is negative 8, and it's in the first position. So you gotta take negative 8 plus its position of 1, and you get negative 7. So our rule says our previous term, to get to this spot, says to our previous term, negative 7 plus its position, which is the second position, you get negative 5. And then to be able to get to our fourth term, you take the previous term, which is negative 5, plus its position, which is 3, and you get negative 2. And we pretty much have to do the same thing here. You'll notice your subscript here is one smaller than that, so once again it means previous term. So we're going to start out with our 9, and then our formula says previous term. Now you notice this n here matches this, so that's the term that we're dealing with, which is our current term. So if we're looking for our second term, we got to take our previous term, which is 9, and add the position that we're in, which is 2. 9 plus 2, we know, is 11. To be able to get to our third term, we got to take our previous term, which is 11, plus our current position, which is 3, and you get 14. And then we go ahead, we do our next term, which we got to take our previous term of 14 and add the position that we're in, which is 4, so we get 18. And we're almost done here. We also have to talk about iterations. We need to find our first iterations. We have a rule here that says 2 times our input minus 1. So if we are looking for our first iteration, all we have to do is take this, plug it in for our input, which is 3. 2 times 3 minus 1, that's 6 minus 1, and that's 5. And so then all we have to do to find our next iteration is take that 5, plug it in, and that tells us we end up getting our next iteration, 2 times 5 minus 1, that's 9. And then we have to go ahead and go plug that into our rule, which says 2 times our input minus 1. So if we plug in our 9, 2 times 9 minus 1, and we get 17. So let's take a moment to read through this. So you pause it and read through. So we are wondering how far this is going to end up being. We're at 70 feet. And then we go up 95% of that, so 70 times 0.95, which is really a 66.5. And then we have to go up another 95%, so we're multiplying by another 95. So we take that 665 times 0.95, and in this case that's 63.175 plus, and it keeps doing this. Now you'll notice this is an infinite geometric series. Our first term is 70. And didn't you notice that each time we're multiplying by 0.95? So that's your r, which is 0.95. So we can use our formula, your first term over 1 minus r. Our first term is 70 over 1 minus r, which is 0.95. And then all we have to do is just type that into our handy dandy calculator. If you type it in all at once, put the whole bottom in parentheses, and you get 1,400 feet.